Yes, we are now ready to begin with the real work of the class. We talked last time about the structure of the class, and certainly as we work our way through the first three chapters, what I said about that structure, we'll start to sort of fill that in. We'll give definitions, postulates, and then start to prove theorems. But here we go in chapter one with primarily definitions together with diagrams of typical kinds of objects and how it is that we label those diagrams. These are background skills that you simply must have. Now, this first section is about objects that I sometimes call straights, points, lines, segments, rays, and polygons. They're all either lines or made up of pieces of lines ultimately. So I'll move through this fairly quickly because I assume that you'll be familiar with this material. So here we go. Quickly, we will do this. So I will give you definitions in this section. Okay. There will be definitions of point, line, segment, ray, and polygon. Ultimately, a few others as well, but those are the primary ones. Those are the primary ones. And I will also show you how we draw these. That is how we represent them in diagrams. And I will also teach you how to name them. These are basic skills for this class, as I said. Now, for the definition of point, we will use Euclid's definition. Sometimes we will use Euclid's definitions, and sometimes we will not. In this case, we do. Saith Euclid, a point is that which has no part. Let that sink in. A point is that which has no part. It is, as it were, as small as a geometrical object can be, because if it were larger than the small as it could be, it would have parts to it, wouldn't it? It would have like a left and a right and a top and a bottom and so on. So as soon as we say that it has no parts at all, it seems that it is as small as possible, and this is precisely what we mean by point. We name points with capital letters, and we picture them with dots typically. So you see here a diagram, the points A, B, C, and D, and they are labeled with capital letters. And please do pay close attention to our use for capital letters. They name points and they will name nothing else in this class. So you do not get to decide for yourself what capital letters name. I have told you what they name. They name points, and they always name points. Everything else in this class, everything that we will study, lines, triangles, quadrilaterals, circles, everything else, they're ultimately just collections of points. They are, as it were, many points. Okay, so ultimately, what we study in this class are points and various ways in which points can be arranged. Now, lines. We'll follow definition. We'll follow Euclid's definition on this as well. Euclid says that a line is limitless, breadthless, length. Okay, let's think about that for just a moment. Limitless. That means that it is infinite, as we will see in each of two directions, and it is also breadthless. That is, it has length, but it does not have breadth. If you like to think of it this way, we can say then that lines are one-dimensional objects. They have length, but they do not have breadth. Now, we often name lines with lowercase letters like lowercase a, b, c, and so on. Now, typically we don't place arrows on the ends of the picture of a line. Instead, context will, I believe, always make clear whether we mean a line or perhaps just a piece of a line. So you see in front of you a typical picture of a line. Arrows on the end necessary because I have told you that it is a line, and we have labeled that with a lowercase a. Now, in just a moment, we'll have another way to label lines, actually a more common way, but we have a little bit of work to do before we get there. Now, postulates. Okay, we won't have too many postulates in this chapter because primarily our work is definition, but we will have need of a few postulates because it will be necessary for us to have them to give all the definitions we want to give and to draw the diagrams we wish to draw. So let me propose to you a certain postulate. Okay. And again, as we said in the previous section, a postulate is a basic assumption that I believe you will find obviously true. So let me propose to you this postulate, our first official postulate for the class. It's called the line existent postulate. It says this: for any pair of points, a line exists that passes through them. Moreover, that line is unique. That is, only one line passes through a pair of points. So think of it like this. If in this class you're given a pair of points, you know that a line exists that passes through them. And this is quite independent of whether the line has been drawn or not. This postulate guarantees the existence of that line, which means, of course, we may draw it if we wish. But that it has been drawn is not required for its existence. Rather, the existence of the points thereby immediately guarantees the existence of the line. And moreover, for any pair of points, the line that passes through them is unique. It's the only one. Okay, so another way to put this is that for any given pair of points, one and only one line passes through them. Now, the reason that I introduced this postulate at this early time in the class is because it gives rise to a second way to name lines, which is actually the more common of the second way to name lines. Now, given that the line through a pair of points is unique, we may use any 2 points on a line to name that line. So for instance, I have line lowercase a, as up before, but now I have 2 points on that line, points A and B, and notice again that those are capitalized because those are points. And then we can use those 2 letters to name the line. We can call this line AB, or we can write AB with the line symbol on top, which I will circle for you. And notice that that line symbol on top does have the arrows because we need the symbol to say that this is indeed a line. So that's another way to name a line, either lowercase letter or a pair of uppercase letters. Here's an obvious point about the use of point names to name lines. There's nothing special about those 2 points A and B on the line. We could have used any 2 points on the line. So once we add a third point on the line, the point C as you see, we could have called this line AB, line AC, or of course line BC as well. Now a second obvious point, the order of the letters in the name of a line is irrelevant. So the line AB is also the line BA. And why is that the case? Because it doesn't matter the order in which you give the points. The line that passes through them is that same unique line, as is guaranteed by the line existence postulate. Collinear. We say that 2 or more points are collinear when they all lie on a single line. So as is shown in the diagram, we see that points M, O, and N are collinear. Between, we use this in a very particular kind of way. When we say that one point is between 2 others, we mean that they are collinear. Okay, so betweenness implies collinearity. That's the only way we use the word betweenness. So in the diagram, you see that O is between points M and N because they all do lie on a line, but we will not say in this class that point P is in between points M and N because P does not lie on the line that passes through M and N. So it cannot be between. Now, line segment. Line segments are derived in some sense from lines. So a line segment is 2 points from a line and all points from that line between those 2 points. We call those 2 points the endpoints of the segment. So here's the typical diagram for a line segment with its pair of endpoints. As for segment names, we have to use the endpoints, okay? We have to use the endpoints if we use any points at all. So the line segment that you see below, his endpoints are A and B. We can call that line segment AB or line segment BA, and we can do that symbolically with the little line segment symbol on top of either AB or BA. And notice that we don't have arrows on the end of those to indicate that that is indeed a line segment. Ray. A ray is a kind of intermediary between a point, a segment and a line. A ray is like infinite in one direction, but not in the other. The precise definition, however, the one that I will expect you to know, is that a ray is a point on a line and all points from that line on a given side of that point. Okay, so then a ray has a single endpoint, as is shown in the diagram below. Now, as for how we name a ray, we have to be careful here. In the case of lines and segments, the order of the points that were used to name the object was irrelevant, but that is not true in the case of array. When we name array, we have to use the endpoint. The endpoint must come first. So look at the array that you see there in the diagram. It's an array with endpoint A that passes through B and also passes through C. So valid names would be AB and AC. And notice in both of those, that the endpoint comes first. So C, A is first. Now, any name, any attempt to name this array that does not begin with an A would be invalid. Okay, so you notice that there's a BA, apparently an attempt to name this array. Well, that is not correct because array BA actually would start at B and pass through A. Array CA would start at C and pass through A. Array BC would start at B and pass through C. And array CB would start at C and pass through B. Now, just a side point here, something to make sure that you really understand what we've done so far. Those invalid names, they are names of arrays that exist. Okay, so the array BA would be an array that starts at B and passes through A, and that has not been pictured on the diagram, but notice that by the line existence postulate, the line through A and B, which is infinite in both directions, does exist. Okay, and we can pull out the ray that starts at B and passes through A from that. So when I say that BA is an invalid name for the ray pictured in the diagram, I don't mean to say that the ray BA does not exist. It most certainly does exist. It's just a different ray. Okay, it's just a different ray than the ray AB, or if you like, AC. Polygon. We won't have much talk of polygon until really chapter 4, but I'll go ahead and define it here because we can easily do so given the other definitions that have been given. The polygon is a collection of segments, right? No surprise there, in which each intersects two others and does so at its endpoints. Okay. Now that second part might be a bit of a surprise, but if you look at the diagram, I think the point is really fairly obvious. So look at the polygon in the diagram that goes from points A to B to C to D. Notice that it is composed of line segments, segment AB and BC and CD and AD. And notice that each of those intersects two others and does so at its endpoints. Okay, so look for instance at line segment AB. It intersects BC, line segment BC at B, and it intersects line segment AD at D. So each line segment, and all the others the same is true, so every line segment intersects two others and does so at its endpoints. And when we do this, we get a polygon. Those segments that together compose the polygon, or it's called its sides, and the points of intersection of the sides are called the vertices, which in this case are A and B and C and D. So as for how we name polygons, it's really a very simple matter. We make use of the names of the vertices, which are points. And notice what's happened here, okay? We've used points to name lines, to name segments, to name rays, and now we use them to name polygons. And indeed, in this class, point names are the most common way to name other kinds of objects. We use points on the object to name the object in accordance with some rule for how it is that we name objects of that type. Okay, and it's certainly true of polygons as well. So a way to name this polygon, by far the most common way, is to use the vertices. And the way you do that in particular is you choose a vertex in a direction, either clockwise or counterclockwise, and then you travel around the polygon from vertex to vertex, and you simply list out the vertices as you find them. So we could start at A and go clockwise, and we would have the name ABCD, perfectly valid. Or we could start at C and go clockwise, in which case we would go from C to D to A to B, also a perfectly valid name. Or we could start at D and go counterclockwise, where we would then go from D to C to B to A. Perfectly fine. One possible invalid name would be BDCA. And notice the reason why that's invalid. As we go from B to D, we skipped a vertex, okay? We either skipped C or we skipped A, depends on the direction that we travel around, but we did skip a vertex. So you have to go from from vertex to adjacent vertex in some direction. Polygon types. No doubt you're familiar with the categorization of polygons based upon the number of sides and the words that are used for this. So a triangle is a three-sided polygon. A quadrilateral is a four-sided polygon, and so on. Now, there's a very convenient way to name a polygon with a certain number of sides. You use the name of the form n-gon. So, for instance, a triangle can be called a three-gon. A quadrilateral can be called a four-gon. A 23-sided polygon can be called a 23-gon. And I suspect then that you recognize the convenience of names of that sort. Who knows what the actual Greek name is for the number 23? I don't, but I can certainly call a polygon a 23-gon. Intersection, actually, I realized a word that I've used already, so let's make sure that we understand what this means. The intersection of two geometrical objects is the set of points that lie on both. That is, it's what's common, or perhaps even more precisely, it's all and only those points that are parts of both. Okay, so here's an example in the diagram. I have a line A and a line B. They share the point Z in common, that is, Z is on both, so the point Z is their intersection. Here's another example. I have triangles WXZ. That's the triangle on the left-hand side. I have the triangle XYZ. That's the triangle on the right-hand side. And notice that both of those triangles contain the segment X down to Z. That segment is part of both. So all of that segment, all the points of that segment, which is just the segment, is in the intersection of triangles WXZ and XYZ. And that's it for our first set of definitions. That's our discussion of the straights. On the assignment, you will just simply rehearse all of this. You will be given descriptions that you must turn into diagrams. You will be given diagrams that you will then turn into descriptions, and you will be asked about information that can be inferred from various diagrams.